The Chesapeake Bay is the largest estuary in the United States and the third largest on Earth. Spanning more than 64,000 square miles, the Chesapeake Bay watershed encompasses portions of New York, Pennsylvania, Delaware, Maryland, West Virginia, Virginia, and the District of Columbia. Shared by 18 million people and 3,600 species of plants and animals, the Chesapeake Bay is considered to be one of the most biologically active and productive estuaries on the planet. Despite being a hotspot for biological activity, the Chesapeake Bay is in need of our help. From centuries of over-harvesting, pollution, disease, and now more recently climate change, the Chesapeake Bay fights to support all life that flows through its veins. In the past few decades, the Chesapeake Bay has gained national attention as a case study area for implementing environmental regulations and ecosystem restoration projects. Research universities, all levels of government, and non-governmental organizations are working together to help provide solutions to solve some of the greatest threats facing the Chesapeake. Today, the Chesapeake Bay is starting to see a rebound in its overall health. However, there is uncertainty as to whether the Chesapeake Bay will continue to improve if pollution mitigation targets are not met, or funding for further research and restoration projects are reduced. Come follow along on this journey through the Chesapeake Bay watershed as we take a closer look into some of the incredibly resilient habitats and its wildlife. From burning fossil fuels in our everyday lives, large amounts of carbon dioxide is released into the atmosphere. Never before in the entirety of humans' existence have CO2 concentrations been so high. Forest coverage is one of Earth's best chances at lowering global CO2 emissions. At one point, forests covered 95% of the watershed. Now it covers roughly 57%. Through the power of photosynthesis, plants absorb carbon dioxide as part of their respiration process. As a byproduct of plant respiration, the oxygen we breathe gets produced. Competing for the sun's light and available resources, trees form dense canopies that limit light from penetrating through to the forest floor. When trees die, it creates holes in the canopy. These holes allow for young saplings and other new growth to take over in the next stage of ecological succession. With the forests that remain, they not only help sequester carbon dioxide, but they also help sustain an incredible amount of biodiversity. Prior to large-scale deforestation practices, squirrels were once able to make their way as far south as Georgia without ever leaving the tree canopy. Now, with forest fragmentation, squirrels and many other animals are constrained to their isolated wilderness areas. The eastern box turtle is one of only a few terrestrial-based turtles. These turtles prefer the coverage of the wooded forest than the water. However, it's not uncommon to find them cooling off in nearby shallow waters. Quite fascinatingly about these turtles is that they can be sexed by the coloration of their eyes. Males have red, while females have yellow and brown. As the sun begins to set, some animals begin to seek shelter and call it a night. For others, their day is just beginning. Bats use echolocation to navigate through the dark. This adaptation helps them find food while avoiding trees and other obstacles. During the night, bats consume thousands of insects like mosquitoes, moths, and many others. Sadly, these flying creatures of the night are under serious threat from white nose syndrome, a deadly disease that has spread to over half the continent. This disease causes infected bats to use up all of their winter fat reserves before the arrival of spring. Eventually, the infected bats will die from starvation or freeze to death as they search for food. To minimize the spread of white nose syndrome, a national action plan has been implemented to create guidelines for humans entering bat habitats and a decontamination protocol to prevent the transmission of the disease to areas currently not infected. Wetlands provide critical habitat for many of the bay's residents, as well as other ecosystem services. These important habitats act like giant sponges, absorbing large amounts of water from flooding and storm surges. In addition to trapping water, they also store excess nutrients and pollutants from runoff. Found mainly along the shores of the Chesapeake Bay and tidal portions of rivers, estuarine wetlands take shape as tidal marshes. These are areas that get flooded tidally and are adapted to higher salinity water concentrations. As the tides recede, the marsh bed reveals a temporarily hidden world. The fiddler crab is a small crustacean that lives throughout much of the Chesapeake Bay. Male fiddler crabs have a single large claw that he will wave around during mating season. This waving motion mesmerizes potential mates, but it also attracts the attention of fellow male competitors. When not competing for mates, the fiddler crab spends its time on the marsh bed feeding. With their small claws, the fiddler crab feeds on algae and other organic matter in sediments. While eating, fiddler crabs will deposit little ball-shaped excrements. These little mounds can be found all over the marsh bed before the tide rises and washes them away. With the moon's gravitational pull to the Earth, twice a day, the tides rise and fall. Like clockwork, the fiddler crabs know when it's time to leave and go home. Palustrine wetlands range from freshwater bogs, non-tidal marshes, swamps that border streams and rivers, to ponds and lakes. On this summer day, turtles crowd a partially submerged tree. Using the sun to warm their body temperatures, these cold-blooded reptiles depend on fallen trees and the nearby embankments for thermoregulation. As juveniles, painted shell turtles are omnivores, but grow up to become herbivores when adults. Year after year, critical habitats from forest to wetlands and the shore are lost to urbanization and sea level rise. With the decrease in wilderness areas, animals like birds and insects are immediately feeling the impacts. Birds from all habitats are affected, even birds that are seen every day, are now becoming less common. In the last 50 years, bird populations in North America have plummeted by nearly 3 billion birds in a newly released study from the Cornell Lab of Ornithology. With the vastness in ecosystem diversity the Chesapeake Bay watershed has to offer, it too is seeing a drastic decline in bird populations. During the fall and winter, the Chesapeake Bay becomes a source to one of the largest bird migration routes on the planet. Hundreds of thousands to millions of birds seek refuge in these waters during the winter. Much like the birds, insects are also seeing a massive decline. Insect populations have plummeted due to the unsustainable practices from homogenized agriculture, pesticides, habitat loss, and disease. 3/4 of the world's flowering plants and 35% of the global food supply depend on the pollinators. Scientists estimate that 1 out of every 3 bites of food you consume is because of pollinators like bees, butterflies, moths, birds, bats, and many other insects. Insects are low in the trophic level classification. This means that everything in higher trophic levels will be affected from a rapidly declining population. Due to the Chesapeake Bay's location in the mid-Atlantic, it is not immune to strong storm systems like hurricanes. After Hurricane Dorian devastated the Caribbean, it made its way along the East Coast, pushing large amounts of water inland. Coastal flooding, strong winds, and destruction follow. As the bay's first line of defense, wetlands and marshes help abate the wrath of the storm's power. With their absorption capabilities, wetlands can help lower the extent of coastal flooding. Wetland vegetation plays an integral role in storm system management. Due to its densely packed grasses, the grasses reduce the water's velocity through the meandering channels, allowing for the sediment to settle out of the water column. Over time, the accumulation of sediment grows the marsh vertically in a process called accretion. Accretion is critical for the future of the Chesapeake Bay and its wetlands. If rates of accretion are not able to keep up with sea level rise and land subsidence, the constant and prolonged flooding of wetland vegetation will begin to die and decompose. In time, the exposed marsh beds will become eroded away and turn into mudflats and large open water areas, making the area more prone to habitat loss and destruction. Invisible to the organisms in the water, dead zones are areas in the water where dissolved oxygen is nearly non-existent. Photosynthetic algae uptake the excess nutrients and form large concentrations of algae called algal blooms. These blooms block large amounts of light from penetrating the water column. In the bay, submerged aquatic vegetation once was found at depths of 2 meters. Now, with the amount of pollution increasing the bay's turbidity, submerged aquatic vegetation is now only found at depths up to 1 meter. This massive reduction in spatial distribution puts tremendous stress on the ability of submerged aquatic vegetation to exist in an already stressful environment. When the algae dies, it sinks to the bottom of the bay and begins to decompose. During decomposition, the bacteria consume large quantities of dissolved oxygen to break down the organic matter, leaving behind tremendous amounts of methane and carbon dioxide in its place. With limited sources of oxygen production, the water becomes dead. Over time, environmental and meteorological conditions will eventually meet a threshold, allowing for the waters to become oxygenated once again. The Chesapeake Bay is a massive ecosystem. With all of its different habitats and wildlife, they all are a part of a giant web of interconnections. When these connections are disrupted, it sends shockwaves throughout the region. It not only impacts the wildlife, but also the people who love and call this place home. Through grassroots environmental activism, research, regulations, non-governmental organizations, and the creation of the Chesapeake Bay program, the tides are starting to turn in the right direction. The research is conclusive that when regulations are in place to mitigate nutrient runoff from wastewater treatment facilities, agriculture, and urban areas, this significantly lowers the amount of nitrogen and phosphorus entering the bay. This change alone is enough to lower turbidity and algal blooms, all the while increasing the ecosystem services of wetlands, oysters, and submerged aquatic vegetation. In the Chesapeake Bay, the recovery and restoration of eelgrass has become the largest recovery effort in the world for submerged aquatic vegetation. Through strict enforcement of harvesting regulations for blue crabs and oysters, their populations are starting to rebound. In the 2019 annual winter survey of blue crabs, surveyors recorded the 8th highest population level seen in the last 30 years. Success stories like this are not uncommon. Every year, more and more stories are being released by research studies and environmental organizations about the wildlife coming back. The fate of the Chesapeake Bay depends on our continued enforcement of regulations, funding for projects, and the will of the people. We have the ability right now to save the Chesapeake, or we can destroy it. It's up to us to protect this national treasure. Together, we can save the Bay.